And I'm going to turn off the AC. Okay, so it looks like we're getting a few more people in now, which is good to see. Who do we have? Sarah, hi Sarah. We have Abdullah Ahmadi and Aisha. Okay. Hi everybody. So we have maybe about, I'm doing okay, you know, things considered. We have about 20 students in this class, somewhere between 15 and 20. I can't keep track exactly. The register keeps changing, students keep coming from section to section, but we should have about 20. So today we have 6 people. I don't know where everybody else is. Last time I looked at the WhatsApp, there was like a million messages saying, how do I get into class? Where am I? Who is this? What day is this? But hopefully they all figure it out. Hi, Jocelyn. So I'll get started, and you know, if you have questions as things come up, you let me know, okay? So first things first, if you missed yesterday's class, that means you've missed 2 classes worth of material. In fact, a little bit more than 2 classes, because with Ramadan as well, we have to go even faster than normal. It is what it is. That's why those videos are there. If you watch every single video in this course and do the practice, that is the content. That is everything. You haven't missed anything. The problem is, if you don't watch the videos, you won't know the topics so well, because in these classes, these Zoom classes, it's mostly going to be me summarizing the topic, trying to make it as easy as I can for you, and then doing practice problems. So I'm kind of like an extra resource, because it's a flipped classroom sort of thing, right? You watch the videos and then you get the extra help. So if anyone's confused, you know, why is he not teaching every single thing? Well, because this format doesn't allow me to teach every single thing. So I hope that makes sense to you. But of course, I'm always here to help. I'm pretty much always by my phone and everything else. So just, it will be overwhelming in the beginning for many of you, and that's just the way it's going to be. But as the weeks go on, you will settle into the course better. The only thing I'll ask is that you don't get lazy. I know there's only so much to do. I know it's Ramadan, but really everything's closed. What else are you going to do? So, you know, put the time in and you can get an A in this course. So let's get started. If there's no questions, I'll get started. Just let me know anytime if you do have questions, okay? So what we did yesterday is we defined the imaginary unit. You know, I'm just looking at this list here, obviously. We defined the imaginary unit. J is root of -1. If you get the square root of a number, usually it pops out a square root. If you get a square root of a negative number, it pops out this J term, which is the imaginary term or a complex. We simplified them, we added them together, multiplied them, divided them, all the regular stuff that we normally do with numbers, except we have a J in there that we have to consider. And then we graphed it. And graphing it is pretty much the same as graphing just a point on a piece of graph paper, but you need to connect the point to the origin with a line. So let me show you what I mean. So we did all of this. By the way, I'm going to post, by the end of this unit, I will have 3 things posted in terms of notes, in terms of answers. I'm going to have the single answers, which are just the final answers for everything. That's already on D2L. I'm going to post my handwritten notes, which is still not everything, but it's everything I covered in class. So you can see, you know, what I'm looking at right now, all this stuff. You will get a copy of that for your section. And you'll also get a full answer booklet, which has every question worked out, because it's so fast and intense right now that I'm trying to give you as much, as many resources as I can. And you choose to use them at your leisure. You know, use everything you can to get you through this course. All right, and the important things here, I'll just show you what we got to yesterday. We solved some stuff. I told you rectangular form looks like this, which means, oops, we can have a number that's a real part. We call it a real number. And then we'll have another number which has a J term attached to it. That's called the imaginary number. It's still a number, so it's really not imaginary, but we call it imaginary because it comes from the negative square root. So if you see numbers that are a number and then a little J part, that means it's called a complex number. And then I showed you that you could graph these. You can go back and watch the videos on how to multiply them, add them, and so on. But we got all the way down to graphing complex numbers. So this is what I meant when I said, I'll just do a quick example. You look at your imaginary number here, that's a -3 and a -2J. that means that your real part is -3 and your imaginary part is -2. That means that you treat it like x and y. You know, the x term comes first, the y term comes second. It's very similar. That means in this case, you would go left 3. So 1, 2, 3 to the left, and then you would go down 2, 1, 2, because -2, and just connect the start to the end point. So you should have basically just an arrow, also known as a vector, that represents the number. So when you look at it, you can say, hey, I went left 3 and down 2. Everything is fully described. So hopefully that makes some sort of sense. Here I've said -5 means left 5, which it does. +2 means up 2, which it does. Same thing as graphing regular coordinates. Oops, what have I done? If you want to think of it as coordinates, just it's -5 and 2. That point is there, and you just connect the line, okay? The only trick comes in when we have more than one, and we have to use tip to tail method. So hopefully if you've done physics, which I think most of you have, you'll understand what tip to tail means. You start at the end of the vector. So before I finish the review, because again, I haven't started anything new yet, I want to show you kind of a summary of the key things I think you should know by now. So first of all, and I will make this available to you, you need to know all these rules, which we covered yesterday. That's all your j terms, j to the power of 1, power of 2, power of 3, and power of 4. They all have different results, which are right there. You don't need to memorize them because you can have them in front of you. You can write them on a piece of paper and be looking at them all the time if you want. But I do recommend that you memorize them. We covered what the conjugate meant. The conjugate means that if you have an imaginary number, you flip the sign next to the j term. And I showed you how to do that a few times. And we added, subtracted, multiplied, and divide. Note that when you add, you take the real parts, add them together, and then take the imaginary parts and add those together. This shouldn't be anything too new because look, if you had 3 plus x, or sorry, 3 plus 4x, plus 5 minus 7x, every single one of you could do that already. You would just add the constants, the 3 and 5, and you would work on the x's on their own, the like terms. So it's the exact same thing. There's nothing new. The only thing that's new is sometimes when you get an exponent, it turns into something more fancy, all right? And then we added subtracted complex numbers using a graph, all right? So I've caught you up a little bit. Before I actually start the practice, are there any questions? Or have you already started texting? Or has your mind wandered up to space somewhere? Anybody? Everyone's still here. Everyone's asleep. Hello, hello. Okay. All right. So Sarah says it's easy. That's good to hear. If it's not easy, that's what you need to let me know. Otherwise, let's get started, okay? In this case, we have a 5 minus j. That's a complex number. I'm going to draw that. I'll go right 5 and down 1. You know, that's the same as 5 up minus 1 down, or 1j. So that will be at this point here. So I know a lot of you might not have a printer, and that's okay, but you should at least understand how to sketch these things. That's the first vector. You'll notice I'm adding vectors here. So I'm going to take the other one, I'll make it a different color. That's 3 right, up 2. Okay, so it should look like this. The problem is, I don't go from the center anymore. I don't go from the origin. I go from the tip of the first arrow. So I go right 3, 1, 2, 3. I don't have a whole lot of space here, 1, 2, 3. I'm just gonna, it's a badly made example apparently, and up 2 from that, 1, 2. It should look like this. Okay, those are my 2 vectors. The first one looked like this. The next one added up. So at the end, I connect them from start to finish. Starting point, end point, and I'll use this thing as a ruler. It has ruler in OneNote, but I actually find this is a little easier. I don't know where this giant thing came from. I think my wife was making some clothes or something. Anyway, that's our finishing vector, and the final answer is whatever that vector gives us. So what is the size of that vector? What's that complex number now? What's our final answer? Can someone give me that? when you count how many parts over it went, how many did it go? You know, what's the X value for that last point? Is there anybody out there?
What?
It's 8, because from start to finish here, I've gone 8. That's what I'm asking. So we will say 8 is the real term. That's how far on that. And then plus 2j.
Plus 1 to be.
1j, or plus j.
Yep.
It's if you notice, it's only gone up 1 from the beginning. You'll notice here, from the origin to the end point, it's just 1. So careful on that. Also, we can check our answer. Let me move this over here. Let's check our answer by adding. So we look at the original question, 5 minus j plus 3 plus 2j. Add the real terms, add 5 and 3, that gives 8. And then negative j plus 2j, well, that would give us positive j. And so the final answer is 8 plus j, and they match. 8 plus j, 8 plus j. It's the same thing. Okay, so you should always be able to check your answer by doing it by hand, or doing it numerically, we call it. So I'm going to move on to another example. I don't know why this one is broken from page to page, but you know, it is what it is. It's COVID time. It's a weird time for everybody. Let me just do this numerically first, and then I'll check it by graphing. So first of all, this negative in front is going to cause me a problem. I'm going to change it to a positive and change all the signs inside the bracket next to it. So this is 3 minus 2j. I'm going to change this to a positive and then change the sign, bring the sign inside. So what that means is there'll be a negative 4 inside and a positive 6j. And the reason I do that is it's much easier to add vectors that way instead of thinking subtraction. So I'm going to change my mind. I'm going to graph this right now. So 3 minus 2j is 3 right down 2. So that's this. 3 right down 2. The second one is left 4 up 6 from that point. So 1, 2, 3, 4. That's left 4 up 6. 1, 2, 3, 4, 5, 6. I need to do this. So I'm allowed to kind of come back. Final answer. Abdullah, can you mute, please?
Yes.
Can you mute that?
Ah, okay. I mean, put mute. Okay. Sorry.
It was a bit loud. I don't know if you're talking or if there's something else going on. It was just a little bit loud. So from
No,
start
actually,
to finish,
okay.
at start to finish, it looks like this. So you should be able to see that from in the end of the day, that just this red one, again, this is what I'm talking about, just this vector, that is -1, +4, or -1 plus 4, left 1, up 4. Let me go back and check the answer. If you have 3 minus 4, that's -1. And if you have -2 plus 6, that should be +4. And so both ways confirm each other. It confirms it by graphing it, and you can confirm it by doing it by hand. All right? So in this case, let me, hopefully you can still see that. I'll leave some on the page. In this case, I'd like you to try D, okay? We have 3 vectors. I'll just rewrite it for you first. This is J plus 2 plus J plus 3 plus 2j. So I'd like you to try that, at least get the numerical answer. Notice that the first vector should look like this, straight up. The second vector should look like this. And the third vector, I don't have a color for it, should look like this. Okay, I want you to try that.
It's gonna be 4j plus 5.
4j plus 5. So what we should do is the 5 would come in front because it makes no difference, but it always is best to put the coefficients first. So you're saying it should be 5 plus 4j?
Yes.
I think you're right. I'm hoping just for one or two other answers for that. It should only take about 30 seconds to do this, really, maybe not even. So if anyone else could give it a shot. And then we'll move on to the next topic. This is actually just a summary of the last topic. So hopefully that's enough time. Let's see. I do agree with you. I think it is 5 plus 4j. That's because if we look at just the real terms, that's 2 and 3. That's a 5. If we just look at the imaginary terms, that's 1j, 1j, 2j, so 4j's in total. So 5 plus 4j. So at the end of the day here, I should have that. Let me just draw it and show you. 5 and 4 should look like this. And then I'll go back and try each one. So it was, the first one was j, it should look like this. And then it should be right 2 up 1, should look like this. We've drawn that in purple, I guess, if I'm going to be consistent. And then the last one, orange, is 3 over and up 2. So yeah, it should look like this. So we get the exact same thing. Good job, Noran. You're the only one who replied. I'm sure others can do it, but I appreciate people taking the time to actually respond. Because I'm not a YouTube video. Maybe some of you wish that I was, but I'm not. Okay. Is that
Mr.
clear?
Scott,
Yeah.
I need to draw the 3 or the 4 sector or what?
You should draw all the vectors just to show that you understand the method.
Okay. And from the from 0 to the last point, yeah?
Yeah.
Not
So the way
the
there's kind of two ways, two sections to this. The first step is to draw your vectors. One vector, then another vector touches the end, and another vector touches the end. So you know we have tip to tail, one after the other, like this. They grow
Okay.
the vector. And then when you're finished with all of those, you take the beginning point and your end point and you connect those.
Okay.
So draw all the arrows, you know, you go, hey, I'm drawing now, woohoo. This is the best day ever. I've got all these vectors, it's a party time. But at the end of the day, you just go from start to finish. And that's the method. And the final
Okay.
answer is that red one. All right. So that's that topic. I've got to move on. We have a lot to cover today, just like every other day. So let me know if you need help later. I'm just going to get a couple, I've got a few reference notes for myself. I don't want to forget. All right, so we're going to deal with polar form now. What we just finished doing was called rectangular form. Rectangular form. So if we had rectangular form, it's in A plus BJ form. Polar form, my colors are all messed up here. Polar form looks like two things. We have an R term, which is a radius, and it's going to give us an angle. Or we can write it like this. It's going to pop out cosines and sines. So some of you, like Noran, who likes trigonometry, maybe that's a good thing. Others who don't like trigonometry, maybe that's a bad thing. But the idea is we can represent the same thing as we did before, but as polar form. So let me show you what I mean. It says here that given the rectangular form of a complex number, we can apply trig ratios to represent it as an angle and a length, an angle theta and a length r. So we look at this diagram here. Let me try to break it up for you. Let's just say we had a vector that looks like this, r, and of course it has you can break it into components. If you've done physics, this should make some sense. The x component here, based on the angle, should be the r cosine theta. The opposite side should be r sine theta. That shouldn't be news to you. Where this comes from is we'll see, look, A is r cos theta. B, the opposite side, is r sine theta. Again, if you've done physics, this is not new. Hopefully you'll see that, look, the r, the hypotenuse, is going to be a squared plus b squared. Again, that's not new. If you have two sides of a triangle, you square them, get the hypotenuse. And finally, I've run out of colors here. Yellow. The tan of the angle. This angle is given by tan. You'll remember, hopefully, from math class, really the more important angle here, the more important rule, is the theta equals the inverse tan of the opposite side, B, over the adjacent side, A. These rules are going to come back and you're going to see them a lot, okay? So don't get too overwhelmed. I just wanted to set it all up. Basically, everything that I've highlighted here are the pieces we're going to need to work with. But the two main steps here are going to be to find the r value, which we're going to call a radius, also called a modulus, and we'll find the angle, which is called the argument. But at the end of the day, it's just dealing with vectors. So if you understood physics a little bit, you shouldn't have any problem with this. The last thing is this. When we deal with polar form, we're going to be dealing with two different forms, which is what I said in the beginning. So let me stop talking for a second, or let me move on to examples so you can actually see what I'm talking about. This practice question, for example, or I'll show you it as an example because I want to get it clear. I know Tom already did this, but 8. This 8, if we were to graph this, what would it look like? Well, it's just an 8. It's a real number. So we graph it on the real axis. It would look like this. That is, we've been given the full vector. We know what the radius is, or we know what the r value is. It's just the real part right now. It's 8. The reason it's called r is because if we imagine, now this might come over some of your heads, but I'm doing my best here. If you imagine this to be a circle, polar means we're dealing with circles, by the way. It's the radius of a circle. So no matter where that arrow is, we can sort of draw an arrow around it. Let me show you. You know, this would be like this. It's talking about the circle, the radius of a circle. That's why it's called r. Now, let's see if anyone's awake. I need two things. I need a radius and I need an angle. What is my angle going to be with respect to the x-axis?
It will be 0.
Yeah, it'll be 0. Why is it 0 exactly? Do you know?
Because the imaginary number is 0. That means there's no nothing. It's not up or down.
Yeah.
It's
So
an x-axis.
yeah, it's just there and it hasn't moved like this at all. If it was like this, it would be 90 degrees. This way would be 180 degrees and 270. This is just 0 degrees. So we have everything. As soon as we have r and theta, we're done. By the way, I'm going to erase this in a second, but if you did tan of b over a, tan inverse, b is 0, a is 8. If you do tan inverse of that, you get 0. So that's another way. So two ways for polar form. One is the r theta form, which will be 8 theta 0 degrees. Also the r cos theta form. I'm just rewriting it so you can see. And look, we have our r. The r's are in both. And our thetas are in both. Everything else stays the same. These colored things here are the only things you're actually looking for. Well, the radius, again, is 8. Cosine, what was the angle? 0. And sine of 0. Now, you don't need to write that every single time. I mean the cosine of 0, sine of 0. I just wanted you to know that it's something that we do see a lot. Okay? Any questions on that? Because it's just going to build on itself.
So good so far.
I think my cat is trying to enter my room. It sounds like a zombie on the door. Okay, so try these practice. I want you to give A a try and I want you to give B a try. They should only take about 30 seconds each at maximum. I don't know if anyone has cats. They're a pain in the butt. So remember, if you're lost and you're just staring at the screen, or maybe you've already disappeared into the ether here, there's two things we need for polar form. The first thing we need is R, and the second thing we need is theta. Okay, so you're saying R is 5. I'm inclined to agree with you. I would say 5. 5 or negative 5?
No, it will be 5 because it's power.
Well, the R is
Power
always
was,
positive.
okay.
And the reason for that, if we draw this, remember it's a radius, it's a circle, really. The radius of a circle has to have a positive value. You can't have a negative radius of something. And then our angle here.
It's 180.
Half angle is 180 degrees. So we have both things. We've totally described the complex number. It's just 5 that way. It's actually nicer than the rectangular form once you're used to this, in my opinion anyways. So this is 5 theta 180, which is the same as writing 5 cos 180 plus j sine 180. And we'll get more into why we write it that way a little later. But for now, I'm just asking you to do it. So hopefully someone has the answer for the next one. If you don't, just follow along. 12j. That's only complex. So it's 0 to the left and right, but straight up. That's our radius. And then our angle is going to be like this. So R is
90. The angle's 90.
Angle's 90. Thank you. Perfect. What's the R going to be? What's the radius?
0.
No, definitely. It's definitely an arrow, so it definitely exists. It has to have a size, and we've actually been given the size. It's 12. And yeah, exactly. Thanks, Aisha. So it's 12 because, well, for the real reason is because a squared plus b squared. And if there's no a part, it must be all the b part. But we'll get to that in a second. We can see the arrow is 12 big. So that's the final answer, okay? So it's 12, angle 90, which Aisha got. Thank you, Aisha. And then I want to represent it in both forms because I'm trying to help you for later. I know where this course is going, and this will help you a lot later. So 90 degrees for both of those. I'm just going to keep going through these. I want to do C, and then I'll ask you to do D. I'll keep that up there for anyone who's still writing. So first things first, you'll notice I always make a sketch because I like to see things in pictures. So right away, 3 to the right, 9 up. It should look like this. And it's just a sketch. Don't get stressed out over it. You just need to know what quadrant it's in. Is it over here, down there, or down here? And the angle is like this. This is the first case we have where the R is not immediately obvious because it's a mix. You just need to go back. So we look back and back, and we say, how do we find R? It's this. So let me break it down. You've probably seen this before. I know you've seen this before. To get R, you just get the square root of the squares of both legs. So square A, square B, and then get the square root. Let's put that right in context here. So A is 3 and B is 9. So it's the square root of 3 squared plus 9 squared. And that will give, let me get my trusty calculator out, 3 squared plus 9 squared. That's 3 root 10. That's why I like this Calcio calculator. It gives you those forms. You do not need to give it to me in decimal form. If it gives you the exact answer, that's actually the better answer. Just keep it. The second step here, we need to get the angle. And again, we can't take it directly because it's kind of like this. It's on an angle. It's not exactly 30 or 40. We need to use math. The equation I've already given you. It's tan inverse. Thank you. Tan inverse. Tan inverse of what? always your B value, always the B value divided by the A value. And if you're not sure which one's which, well, the A value is always the real part, and the B value is always the imaginary part. So just look for your J, that's your B. Look for your not J, and that's your A. What do we get from this? I should probably have calculated this ahead of time. Did I? Let's see. It looks like it should be 71.6. Thank you. By the way, so Aisha is really the only person who's really responding here. Anyone who's had me as an instructor before, I love it when you check the work, because all it takes is for me to put in one tiny little digit in my calculator wrong, and I'm giving all of you the wrong answer. So if you can check the work, it's not because I'm afraid I'm going to make a mistake. I mean, everyone makes mistakes. It's that I don't want everyone to make the same mistake as I did. So if you do the work yourself, you're more likely to be able to check my work, and we all help each other. Okay. Anyway, we've got our R and we've got our theta, so just put them together. 3 root 10 theta, 71.6. That's one version of polar form. The other version of polar form is 3 root 10 outside of cos 71.6 plus j sine 71.6. And that's kind of our final answer here. So I'm going to put it in a box so you know exactly what I'm talking about. I'm going to make these smaller for when we look back on them later. I like everything to fit on a page whenever possible. So that's the setup for this question. I'd like everyone, that includes those that are slightly falling asleep or have already drifted off, to try C and D. You have the skills that you need to get C and D right now. You will maybe have a little issue with the angle, but go as far as you can, and then I'll discuss what to do with the angles. Okay, so take 5 minutes and work on these. Let me know what answer you get. Has anyone gotten any answers yet?
Root 17, the R.
17 R. So
Root 17 sounds okay.
And theta, it's 194.
Interesting.
Because it's 180. In third spot, it's 180 plus the 14.
I was wondering who would get this in the third quadrant. Did anyone else get that? R equals 4. For which one? No, for D.
Maybe they say because we get root 17, it's 4.1 for D.
Maybe. I think there's two reasons. Maybe root 17 is almost 4, or they're just looking at the real part, which is 4. That is not right. Okay, that's about 5 minutes. I'm going to work through. I think root 17 and 194 are correct, just from what I can remember. But let's see. We have the real part squared plus the imaginary part squared, which is 1, which is 1j. Forget the j for now. You just square it. It's the coefficients. Remember, it's a plus b and the imaginary part. We just care about a and b, not the j. So that gives us root 17. So for sure, that's the r. You know, if you wanted to write it in, you could write it in. You could say that's root 17 right here. Is how big that is. I made a mistake. Root 17. The angle, again, you just use your regular formula tan. I'm going to make things easy for now. Just take the positive values of everything. So it's b over a. So that's 1 over 4. We could take the negative. I'm going to just not for now. And there's a reason for that, which I'm going to discuss a little later in the course. But when you get that, inverse tan of 1 over 4 is 14.0. So I'm seeing 75.96. I don't know about that, Master. I don't know if that's that question. Maybe, you know, make sure your calculator is in degrees, not radians. You want to make sure that it's popping out degrees because we care about the degree term, not radians yet. The problem here is that clearly we've gone 180 already. So the angle can't possibly be 14. The very shortest way, I'm going to explain this for now, and I'll explain it a little more later, is that if you're in quadrant 3, again, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you're in quadrant 3, you take 180 and you add the reference angle, or you add the angle that you've been given here. So the angle is actually 180 plus the angle that your calculator gave you. Now, there's 100 different ways to explain that, but for now, I just want you to remember if it's quadrant 3, add it to 180. And that's where we get the 194 degrees to. It's 194.0, I think, so that's fine. So our two answers are root 17 and the angle is 194. So final answer, our angle 194, which is the same as root 17 cosine of 194 plus j sine of 194. I need to squish up my work a little bit. Sorry, I write a little bit big. You'll get used to it. So basically that kind of fully covers everything except for a few of the angle rules. Is there anything I can re-explain for D? I'm going to put a little aside here, just because I'm thinking maybe that explanation wasn't enough. If you have your angles, okay, think of it this way. You have your 4 quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. When you get your tan angle, there's 4 possible options. The first angle, if it's quadrant 1, it'll give you this acute angle. If it's quadrant 2, it will give you this angle. If it's, or that's the, sorry, the angle it's going to give you, that's the angle you want. If it's quadrant 2, it's going to give you this angle. If it's quadrant 3, it's going to give you this angle. And if it's quadrant 4, it's going to give you this angle. This is the calculator, what the calculator is going to give you, okay? So your short answer here, if it's in quadrant 1, your angle is just going to be whatever your reference angle is. The angle that your calculator pops in. I'm going to go into this a lot more later in the course. I'm just giving you a cheat sheet. in quadrant 2, whatever angle your calculator pops out, you have to say 180 minus the angle. So it should, the angle your calculator pops out here is the alpha. If it's in quadrant 3, your angle should be 180, whatever your calculator gives you. Sorry, 180 added to whatever your calculator gives you. And then if it's in quadrant 4, sorry, I'll organize this a little better in a second. If it's in quadrant 4, your angle is going to be 360 minus whatever your calculator gives you. Okay, so in order here, quadrant 1, quadrant 2, quadrant 3 and 4. That's what you need to do. Whatever your calculator gives you will be that alpha term, and then you do these rules on it. So notice here, our angle, sorry if it's a bit small, our angle here was in quadrant 3. So the calculator popped out this. I should probably change them to alpha. So our rule was this, 180 plus. All right, I know that's a lot to take in, but hopefully you've actually already seen this before. It should be review as far as I know. So I'm just trying to give you the quickest rundown possible. Let me just fix my notes here. This should really be alpha if I'm going to be specific. Okay. Anyway, I'll use that again later. So let's use that rule to figure out E here. R is going to be the square root of A squared and B squared, 6 and 5. So it looks like root 61, and that's exactly what I got, root 61. The angle, first we're just going to put it into tan and see what we get. Inverse tan, 5 over 6, because it's B over A. 5 over 6, that should give us, I think, 39.8. Exactly, thank you. Now, that is clearly not the angle because it's at least 90. The angle that our calculator is giving us is this. It's giving us that weird little angle, the acute angle in the second quadrant. So we need to take it away from 180. Yeah, exactly. Thank you, Aisha. So if you're not sure why, you can refer back to this. It's in the second quadrant. It's 180 minus the angle that the calculator gives you. So 180 minus our random 39.8 there. Well, it's not random, but minus our 39.8, it should be 140.2. I'm going to keep the decimal. I like to keep at least one decimal place. Now our answer is fully described. We have our root and we have our angle. I'm going to make these a little smaller. I learned my lesson from last time. And write my final answer. 61, angle is 140.2 degrees. So just to save time, I'm going to just keep that, but it could of course be in both forms. You could write it in both forms. By both forms, I mean you could also write it in this. Okay, I'm going to move on to the next topic in a minute. Are there any last minute questions here? It's really unfortunate that we're not in a class. Like, some of you were in my class in person before all this. And I really like to go and seeing everyone's work and talking to you, what's your favorite color? What do you do for fun? What's your favorite TV show? And get to know each other a little bit, but c'est la vie, if you know French. Okay, let's move on. We need to write these in rectangular form. We've been given polar form, we want to go to rectangular. So we're going from polar to rectangular, and that's actually very easy. It was done in the videos if you saw them, but all you do is you multiply through the brackets. You open the brackets. Take this R term, multiply it by this, and also multiply it by that. Keep the J where it is. So let me show you. All right, what is 160 multiplied by cosine of 150? So 160 multiplied by cosine of 150. You should have your calculator handy. You'll learn better if you do. I'm getting negative 80 root 3.
It's fine. It's okay.
I'm just making sure I'm in the right.
You can keep it, or
Yeah, I think that's okay. I'm going to, just to make life easier, A's and B's, it's a little easier if they're in decimal form. So I'm just going to go ahead and change it. The calculator does give negative 80 root 3, but for A's and B's, it tends to be a little bit easier to convert it. I'm going to do that, but yes, you could keep it if you wanted to. It makes no real difference, okay? So that term there is negative 139. And then our 160 times sine of 150. And again, you can, I'll show you on the calculator actually, for those of you that have it. Okay. So we're just doing 160. Sorry, I'm trying to get another mouse, but it's hard working from home sometimes. I've used all my mice. So cosine 150, close the bracket. We've got negative 80 root 3, which is the same as negative 139. To save you time, because every time you're going to do this, you got to do cosine and sine. To save you time, just, you can just click back a little bit and delete the cosine and replace it with sine. And then you don't need to input all your numbers again. Of course, it doesn't take that long, but that might save you some time, and that's just 80. So you have 80 now, plus 80. Is that okay? No one? No one's going to yell at me for that?
we should write. Yeah.
That's a pretty common mistake. Students tend to forget the J because they're so busy with the numbers and what the calculator gives them that they don't actually write the J. Maybe that's not you. Maybe you got 100%. So just be careful. But that's it. That's the whole answer. So I'd like you to, I'm going to do C, and then I want you to try B right now. Take a minute, 1 minute, or 30 seconds, and do B. Tell me what you get. Type your answer in the chat. It's about 1 minute, isn't it? So hopefully you have an answer. The first number, what I got anyway, was negative 200.3. And then the second number gave me 92.86, so 92.9 J. Okay. So Nasser, you gave me, let me see here. Just keep an eye on who's chatting. So Aisha, perfect, no problem. I would say round that 8 up to 9, all right? Because the next number after 8 is bigger than 5. You can keep as many decimals as you want, but don't go more than 2 decimals really, because no one wants to see all the decimals. I'm not going to read them. You shouldn't be writing them. You're wasting your time. So keep it at least 1 decimal place, maximum 2. Other than that, it's kind of unnecessary. All right, so those of you that engaged, thank you very much. It's going to help your learning if you do that. In C here, the process is exactly the same, even if it doesn't look like it. The easiest way to do this is first to rewrite it as its other polar form, so we can see the exact multiply. But once you get used to this, you don't need to write this. That's why I'm writing it in pencil. So 86.42, that's our R, and then we're going to go cosine of 94.62 plus J sine of 94.62. Now, you don't need to write that every single time. You can get it in your head and just do it in your head. But the first time around, I think it's important to see that. And notice I'm just copying the R over here. I'm copying the theta over here. Everything else kind of stays the same. It's the same structure every single time. So you don't really need to memorize it. You just, use it for a reference and slowly you'll learn. And then multiply this by this and this by this. When you're done that, the answer should be negative 6.96 plus 86.1 J. Now again, you don't need to show that all this pencil stuff here, you actually don't need to write that down. That was for me trying to help you understand where it comes from. So take, another 30 seconds, try D. And if you can get that, then you've got a pretty good handle on this topic. We'll move on to a slightly different topic.
Minus 4,624, and for J it's minus 197.1.
Decimal? 0.1. I agree.
Yeah, the point, the first one, it's 4,624.8.
0.8, okay. So really it should be 5, I guess.
Okay, fine.
Or keep the decimal. Honestly, I'm not too concerned about the decimals. It's always better to keep some decimals, but we need to make a choice to round it at some point. So use your best judgment. Don't write this. That's all I'm asking. It's crazy. Okay, so we got it. I'm going to move on, but I just want to show you one way to quickly check this stuff, or at least make some sense, connect all the ideas. In A here, okay, A, our final answer should be left a bit and then up a bit. So it should look like this, yeah? And then if you look at your original question, it's 160 and then cosine of 150. So the angle is 150, which means it starts at 0 and goes all the way over into the second quadrant. So it does match. There's a way of kind of knowing if you're on the right track. For the second question, our final answer gives us left and up. So again, should be second quadrant. We see that 155, for example, is in the second quadrant. So again, our answer is not too crazy. For C, let me move this up. For C, again, we know that it should be left and up. So again, second quadrant, just by a little bit. And the fourth one, it is left and down. So it should be in the fourth quadrant, and 182 degrees is a full half turn and then a little bit more down. So definitely it is in the third quadrant. So it's a quick way to just get an idea if your answer even makes a little bit of sense. There's other ways to check it, but this is one of the faster ways, okay? So speaking of that, let's complete that topic just by doing this. We need to give the rectangular and polar forms of the following complex numbers. So let's try for E. Remember, for both of these, we need R and, we need to know what the values are. So in this case, rectangular form, we need A and B. In polar form, we need R and theta. So let's see, we have, it goes 3 to the right. So that's our A. It goes 5 up. That's our B. So I can say our rectangular form is 3 plus 5J. That's my rectangular form. I'm done. I'm done now. For the polar form, it's going to be a little more work. We need to get the value of R. So for polar, we don't have a lot of space to do this, so I'll just do my best. For polar form, R is the square root of A squared and B squared, which is 3 squared and 5 squared. We can look at that. That's 3 and this is 5. the root, let me see, 3 squared and 5 squared, that's root 34. And the angle is what? Well, we know it's always tan of b over a, inverse tan of b over a. 5 over 3. That gives us, inverse tan of 5 over 3 is 59 degrees. So I'm going to just write it down here small. All right, our final answer is root 34, 59 degrees. So my final answers, sorry, there's not a lot of space, so I'm just going to try and make it clear. One of my answers and my second answer. Was that too fast, or is that okay?
No, it's okay.
If it's ever too fast or too slow, please let me know. Again, you can go in the participation tools and just click the little buttons and say, too fast, teacher, too slow, teacher, too boring, teacher, and etc. So F, I'm going to skip. I'd like you to try it as practice for yourself. On that note, remember all the final answers are on D2L. They're all there, every single one of them. The answer document looks like this. So for example, we're working through all this stuff. We're on page 10 or so, all the answers are here. You just go look at it. Check your final answer, and it's a great way to at least know if you're on the right track. Okay, so the next topic looks big. Like it's got this whole page of stuff. And in the videos, it does go through that, but I want to get to the very basics. The very basics of this topic is if you multiply two complex numbers, what happens is the R values are multiplied and the angles are added. So you multiply the terms in front and you add the angles. We'll see exactly why later in the course, but for now I'm giving you the shortest possible way. When you multiply, R is multiplied, angles are added. When you divide, your R values are divided and your angles are subtracted. All right? This is a special rule for polar form or complex numbers. And the easiest way to understand what I mean is just to see an example. So let's just jump straight into the examples. These were done in the notes, but I want to show you my way. So when we look at this example 9, it says perform the indicated operation and write your answer in polar form. You just multiply. This is clearly a multiply. We know it's a multiply because we've got two brackets touching each other. We don't see a fraction. And when we multiply, we will multiply the terms in front, and we are going to add the angles. So I should probably write this on the side. You multiply the R's, and you add the thetas. It's very, very, very easy. I don't say that a lot because I don't want to make people feel bad, but it's very easy. For R is just 4 times 2, so 8. And then our angle is 120 plus 20, so 140. And it says write my answer in polar form, so my final answer is 8 and 140. That's my final answer. So notice they're multiplied. My R values are multiplied, and our thetas add. If it was division, we would divide and subtract. All right. I guess I could make this even more simple, really. It's just the thetas that you're looking for. Sorry, if this coloring is hurting your head, just try to ignore it. I'm trying to make it easier, not harder. Is that clear?
Yep, it's clear.
I'd like you to try these two practice, A and B.
Okay.
They're very fast. You do not need to open the brackets. You use your special rule for multiplication.
It's 24.
I agree.
And the angle it's 211.
211, hey? 115 plus 96, 211, yeah. Now, if it went over 360, we would have to do something special, but for now, we're gonna just keep it the way it is. And that's it. The only thing I forgot was the degree symbol, okay? What about B? Can someone give me an answer for B that's not Abdullah or Aisha or Nasser? You're the only people who ever give me any answers. I know you all have brains out there. I know you're smart people. You've got to be. You've made it this far. You might not be confident, but you can do this.
The R is 19.1 to 2.
R is which one, sorry?
E.
19.52. 19.5. A better angle.
$250.
That's all there is to it, folks. Not for today, but for this particular question. So one thing that sometimes happens, or at least is sometimes asked for on in the questions on quizzes, tests, and things like that, is it wants you to give the answer back in the form that it gave it to you. So what I mean by that is, for example, in this question, this first one, the form was the expanded polar form, the big one. And so sometimes if it wants that, you need to write the whole thing out. So you'd need to write it out like this, okay? I would recommend that if it doesn't ask for a specific form, use the short one. But if it does ask, you've got to write it, you've got to match the original form, okay? So just something to keep in mind. The same thing here, 19.5. That's the same as cosine of 250 plus j sine of 250. So just something to remember. It does sometimes want you to match the original form, whatever it was given in. Actually, I didn't need to give that for the second one. I'll just erase it. But it matches the same form. Okay, so let's move on to C. I'll do the first one, you can do the second one. This is a division. So if it's dividing, it's the same idea, but just a tiny little bit different. The R's divide. So divide the top one by the bottom one. And then the thetas, instead of adding, well, what do you think is going to happen? They're going to subtract. You might notice that they work kind of like exponent rules. Like x, if you had x to the power 4 divided by x to the power 3, it's the same as x to the power 4 minus 3. We end up with the subtraction. And there's a very good reason for that, but we won't get into it quite yet. So what's our answer? What's 9 divided by 3? You can do it in your head.
3 and 205.
Yep, 3. And then
The
our
angle.
cosine, that's 310 minus 105, which is 205, yeah? So 205 plus j sine, and we get our 205 again. Yep, that's it. I've matched the original form, so we're okay. That's the whole question. In D, what are we going to get? Let's see. We have 4 and 8.
1/2.
That's 1 divided by 2. You can
1
write it
over
as
2
5,
and
or you can write it as a half. Angle. Aisha,
120.
20, yeah. 280
220.
minus 60. 220. Perfect. So I'll just write, there's 2 ways to write it, depending on who you are. You might prefer one over the other. Some of you like fractions and some of you hate fractions with a burning passion. So whichever one you prefer, I don't care. They're both exactly the same. It's the same idea. Okay. So that rule is pretty simple. I mean, it was a whole page in the notes trying to explain it, but in my opinion, just get to the point. Just get to the point. If you multiply them, you add the errors. Or sorry, you multiply the errors, you add the thetas. If you divide them, you divide the errors and add the thetas. Divide the errors, subtract the thetas. What time is it? 10? Okay, I have no excuse as to being tired. Okay, so in the next section, it says you need to perform the indicated operation, which means do what it tells you to do, and write the final answer in the same form. So the examples are there as you see them. The practice is here. You'll notice in this case, we've got an addition. We've got a subtraction. So we can't use that rule that we just did. In this case, we've got a multiply. In this case, we've got a divide. So I want you to try these. This is a really good review of almost everything we've done so far, except for the graphing, okay? I'm gonna give you a couple pointers, and then I want you to try and actually do these, try to do these to the best of your ability. The first thing I'll say is you need to change to rectangular form first. The reason for that is you cannot add complex numbers in polar form. It's not possible. It's like if you remember in physics, you can't add vectors together. You need to break them into components first. So the rectangular form is like breaking it into components. I think everyone's done physics here. If you haven't done physics, I'm sorry. But change it to rectangular form first, okay? See if you can get this A. If you can get A, no problem. Try B, try C, try D. But I want you to make sure you can do A and B. C and D are just a type of review. We did those before. So take 5 minutes. How's everyone feeling today? Are you tired already? Day 2?
So tired.
Yeah. I get it. I really do. This is not easy for anybody, including me, including all of your instructors, in fact, and definitely all of you. I get it. I wish there was something I could do to make it better. Unfortunately, I can't. All I can say is that I understand. I was a student once, and I've done online learning before, and I hated it. I hated it. And you don't really have a choice. At least I chose to do online learning. So I get it, but I'm here to support you whatever way I can, okay? All I can say is that you got to do the course. I can't take the course away, but I at least can be here to help you. If you don't put in the work, I can't help you. But for those of you that are focused, I'll do everything in my power to get you through and hopefully get you an A. Okay, so I have a feeling that you're either staring at this, not being able to do it, or you're waiting for me to do it for you or anything in between. So what I'm going to do is
Actually, I'm trying in B.
you're trying B. Okay. So did you get A?
No, I'm just going to B first.
Okay.
Smaller number, easier.
Yeah. I guess so. I didn't even notice that there are these giant numbers. No, it's all similar. So I'll start working through them because, again, I have no way of really knowing who's working on it, unfortunately. If you all had a tablet computer and everything, it would be a whole different thing. I would be doing this course a lot differently, but really it feels like a one-way street right now, so sorry about that. Okay, let me do this as easily as I can for you. First things first, this is added. I told you you can't do addition with polar form, so you need to change the rectangular first. So what I need to do, remember I take this number, multiply it by cosine of the angle, and then take this number and multiply it by sine of the angle. Those two answers are what gives me my rectangular form. So that's negative 3064 plus 6388, I think is what gives me out of that sine. And that's my first term kind of transformed into, that's my first term transformed into rectangular form. Okay, so I took the first piece, they were attached by that angle, I changed the whole thing into rectangular form, which we did earlier today. Now the second piece, do the same thing. Multiply it by cos of the angle, which is 2164, I think, and then multiply it by sine of the angle, which is 4135. And put that J. Once you've got that, we go back to even further for what we've done already. Add the real terms, and then add the imaginary terms. So when we do that, we end up with negative 900, and this giant J term, which is this. So hopefully you're following me so far. This is not the final answer. The reason for that is because it says write the final answer in the same form as the question, and this is not in polar form. So we're going to go one step further and say we need to make it polar form. In fact, I'm going to give myself a little more space. How do I make it into polar form? I need two things. I need r, and I need theta. How do I get r? It's a squared plus b squared.
Yep.
With the square root. So that's big numbers, of course, but 900 squared plus 10523 squared. Whoa. Okay. 10561. Let me just keep it at that. 10,561. The theta, you should remember from either this course or physics or pretty much any other time you've used tan, it's opposite over adjacent, or in this case, b over a. So tan inverse of b over a. B is the j term, a is the real term. What's our b? It's 10523. Let me just write it out so that you know exactly which ones, so you don't get them mixed up. Some students like to put the first one on top, and that's not how it works. I'm also making it positive. Remember I said ignore the negatives for now when you use tan. What I get out of this is, I think, 85.1. We're almost done, but we need to know which quadrant this is. What I mean by that is, look, this number here, what quadrant is this? Maybe I'll make a quadrant over here. It's left and up.
Second.
So it's in quadrant 2, yeah. If it's in quadrant 2, remember my rule from before? What did I do? I said 180 minus the angle that we did. So it's 180
And 4.
minus 85.1. And what that will give us is, 94.9 or 94.9 degrees. So this is getting a little big. I want to make sure I keep it all in one space. So hopefully this is okay if I shrink it down a bit. And then final answer is going to be this and this put together. So 105.61, angle 94.9. So like what happens in many cases in this course, this looks like a tiny little baby question. It's not as little as it seems. Now, of course, I show every single step most of the time, but be careful. Make sure that you read the question carefully and do every step that you need to do. Now, first time around, of course, it's the hardest, but keep working at it. Do as much practice as you can, and you'll be fine. So B is pretty much the same question, except we need to deal with this minus. I'm going to leave that as just an exercise. Final answer should be 13.7 root 259.6. It's basically the same process as I just did, okay? So I just don't want to cover it right now. Are we okay? I want to move on to a few different things.
Doesn't matter if I get different in decimal place, right? I get 13.6 because I don't write the full answer or something. I don't know.
Sorry, can you just repeat the beginning of that again?
Doesn't matter if I get different in decimal place from your answer.
You mean
Okay.
if you got like, instead of 13.7, you got a 13.8 or a 13.72 or a 13.6? Like you got a slightly different number at the end, it doesn't matter. As long as your main answer is very close and your steps make sense, it doesn't, I'm not going to be picky about that.
Okay.
And that goes for everybody. All right, so there's a few more things I want to cover. We've got 10 more minutes left, but I need every single one of them. C, we've already done a question like this. Okay, I'm going to do it very quickly. All you need to do is you expand or open the brackets. We did this yesterday. Okay, that's all you need to do. I'll do it very quickly. This is -10 plus 55j plus 6j. And then it's 3 times -11, which is -33. But we switch the sign because of the j squared, so +33. And then we group the terms together. So what we should get is 23 plus 61j, okay? We did this yesterday. You can watch the videos on that, or just, now you know. For D, can someone tell me again, in one word, what the main idea for this question is? What is the one thing I absolutely need to do to solve this question?
The opposite side for 6 minus 12j.
Yeah, the term on bottom has a j in it. We never want j on bottom of a fraction. So you've got to do the conjugate, which means switch the signs. Or it's not really switch the signs. I guess I should say change the sign. Whatever, change it from a positive to a minus or a minus to a positive. 6 minus 12. So what we see here is we end up getting 15 minus, oops, of course not. This is 6 and 12j is the same, 6 and 12j, but the sign changes. And then you multiply, 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 and the rest kind of comes out, okay? I'm not gonna do every single bit of that because I've already done questions like that, but you expand the brackets, right? Do the whole expansion process, simplify, 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 and it should come out nicely. Let me see, I'll give you the final answer on this. This is, maybe someone has the final answer, I'm not sure, but I'm gonna just try and see if I have it in my notes. Let's see here. Yeah, I hate making people wait, but this is for a good reason. So the answer I got for this was -1/30 minus 19/15j, or -6 minus 228j over 180. So for those of you that try this question, that's what you should get, okay? Again, I've done ones like it already. I did them yesterday, which is the reason why I'm not covering it quite as much now. Before the assignment on Sunday, I'll go through this a little bit more maybe. But for now, I'm gonna move on. Okay, so there's one last thing I wanna cover today. That's exponential form. exponential form is basically, it's like a brother to polar form. It's essentially the same thing, but a little tiny bit different. So polar form looks like this. Exponential form looks like this. So it has a e term, which is our exponential term, but you'll notice that there's still r in both of them, and they're both found the same way. And there is a theta term in both of them, which is essentially found the same way. The big difference is exponential form deals in radians, and polar form deals in degrees. So you need to go and make friends with your radians mode on your calculator. Well, actually, you don't even need to change it to radians mode on the calculator. But the big idea here is we're going to have to take a theta in degrees, if you have degrees, to get to radians. You need to multiply by pi over 180. And to get back from that, you need to multiply by 180 over pi. All right? So some things that maybe you've seen before, or maybe is stashed in the back of your brain somewhere, is now back, so that you need to think about it again. Okay? Let me see what we can do here. All right, let me show you the example. I know this was already done in the video, but I want to make sure that you can understand it with me right now. This question, it says, convert from exponential form to rectangular form and polar form. So this question is given in exponential form, which means it should be obvious because exponent means power. There's a power on the top. And we see here that there's a power on the top of this e, so it is exponential form. What we need to do is change it to rectangular. So the easiest thing is to put it into, probably to put it into polar form first. But let me break it down for you. First things first, we need r. And then we're going to need theta eventually. So r is going to be 2. It's already given. Well, it's the same thing. Our theta is 4.80 radians. If you're wondering where that comes from, it's right there. The problem is, in order to get polar form, we need to change it to degrees first. So we multiply this, 4.80 radians, multiply it by what? How do you get rid of the radians? Well, you put some pi on bottom, that'll cancel it, and put 180 on top. So our angle now, 480 times 180, sorry, 4.80 times 180 divided by pi is 275 degrees. So why did I do that? How did I know to do it? Well, I know to do it because I know that's how we need to get it done. You take the degree in radians, sorry, the angle in radians, and change it to degrees. Now we have everything we need. So in polar form, that means that we have 2 angle 275. That's because of what I showed that earlier. It's the 2, and I have the 275 here. I have everything I need. I have r and theta. I'm done. In rectangular form, it's a little bit more work. But if you remember, we need to take this, multiply it by cosine of that, and take this, multiply it by sine of that. We also did that earlier today. So you can see all these concepts are throwing themselves at us, and we just need to scramble and make sense of it. But just stay focused. You'll be okay. So 2 multiplied by cosine of 275, again, this multiplied by cosine of this, is going to be 0.1, I think, if I remember correctly, or if I did it correctly. 2 times sine of 275 is negative 1.99238, so 1.99 J. And now we have both of our answers. We have our polar form, and we have our rectangular form. Ayesha, you're saying negative 0.17 and negative 1.99. Perfect. You don't need to have the exact decimals, as I have. As long as you have a few decimals, like I said, I'm not going to take off marks for it. right? So that's the big idea. That's how you get from exponential to the other two forms. This is not simple. This isn't stuff you're born being able to do. This is stuff that you get better at by doing more and more practice, okay? So keep that in mind. Try not to get too overwhelmed. Let me just make sure that I have what I need. How far did I want to get? I didn't get as far as I wanted to get today, but that's okay. In the last 2 minutes that we have, I just want to summarize what you need to do. Catch up on the videos. You should have watched 8 videos before this class. I'm not going to pretend that you did, but that's what you're expected to do, and that's what I'm always going to expect, is that you've watched the videos. The other thing is make sure you're getting into the D2L shell. I've put a practice assignment there, and I say it's an assignment. It's really not an assignment. It's a practice. So you go into the Dropbox, and you'll see here that there's a practice assignment. Now, it's not a math assignment. You just need to go in, and what it actually is, it's a student information sheet that I want you to complete. And I want to make sure that you have the ability to scan your work. So what you'll see the information. It'll look a little different for you, of course, but you'll get the instructions. And then the assignment looks like this. Sorry, I'm just trying to bring it up so you can see it. This is the assignment. I want you to either print this, fill it out and rescan it, or do it on a separate piece of paper. Just fill it out. It's 1 page, very simple. Scan it with your phone, put it back in the Dropbox as a PDF. And the reason for that is that on Sunday, when you have an actual assignment to do, I want to make sure that you have the skills to get it from the Dropbox, do it by hand, scan it, put it back in the Dropbox, okay? I'm giving you a chance to practice that before you come back on Sunday and you're saying, sir, I can't open the Dropbox, I don't know how. And I'll say, you should have done the practice assignment, okay? So I'm not trying to freak you out. I just am giving you a chance to practice it before it's worth something, okay? That's about it for today. So what we covered was exponential form, the rectangular form, and polar form. We learned what polar form was in the beginning, how to convert between polar form and rectangular form. There is a lot. Even at the beginning, if we remembered how to do multiply and dividing, we did how to graph it, how to add things that are graphed, all sorts of crazy stuff. How to do quadrants. There is a lot in this course. I didn't even get to what I wanted to get done today. So anyway, stay on top of it. Try not to stress too much. Try not to drink too much coffee. Well, I guess you can't drink coffee as well enough. And take care of yourself. Let me know if you have any questions, okay? I'll leave you alone now. Have a great day. If you're busy, or if you're not busy now, you can always stick around. I've got time to answer a few more questions.
Actually, I have suggestion about test.
Yes.
It's still multiple choice. Why you don't make it 20 or 25 and increase that time?